Hello once again, tribe. Welcome into another part 3 series of the final exam preparation sessions. In this series, we'll be talking about calculus, which is the derivatives and first principle. If you are new to the channel, please be sure that you subscribe so that you won't miss when another videos gets uploaded. And also, if you haven't watched the other part series, please be sure that you go on those part series so that you can also learn those and be ready for your upcoming final exams. Now, without further ado, we're going to start with the first part of the series of the calculus, derivatives, and first principles. Now, in the first part, it's going to be 7.1, 7.2, and 7.3. Now, let's go ahead and go to 7.1 so that I can show you method on how you can find f prime x using first principles. Now, in the first principle, 7.1 says given f of x, right? So let's write f of x is equals to minus x squared plus 7x plus 9. So now here we are given f of x, and then the question says determine f prime x from the first principles. Now, whenever you're given f of x and they want you to find f prime x using first principle, it is important to do this. Now here, the first thing that you do is you need to write your f of x, which is what we did here. And then secondly, we need to write f of x plus h. Now, where does f of x plus h come from? Remember, on the formula that you'll be using, f prime x is the limit, right, as h approaches 0 of f of x plus h minus f of x all divided by h. Now, this f of x plus h comes from that. Now, f of x plus h from this equation is going to be minus x plus h all squared plus 7 into x plus h plus 9. Now, what's the next thing that you need to do here? You need to simplify this. Now, when you simplify this, you should get x squared plus 2xh plus h squared plus 7x plus 7h plus 9. And then now the final solution here is going to be minus x squared minus 2xh minus h squared plus 7x plus 7h plus 9. Now, what do you see here? Here you have f of x plus h being that, and also you have f of x being minus x squared plus 7x plus 9. Now, remember, we're trying to find an easy way to calculate this f prime x. Now, what's the next thing now that you're going to do now that you have your f of x and your f of x plus h? What you're going to do is you're going to take the f of x plus h and subtract f of x. Now let's go ahead and do that. F of x is minus x squared minus 2xh minus h squared plus 7x plus 7h plus 9. Now, what about f of x? So we want to say minus. Now, f of x is minus x squared plus 7x plus 9. Right, now let's go ahead and simplify this. So this is going to be minus x squared minus 2xh minus h squared plus 7x plus 7h plus 9 plus x squared minus 7x minus 9. Now, as you can see here, this one cancels with that, and this one cancels with that one, and that one cancels with that one. And then here we are left with minus 2xh minus h squared plus 7h. Now, from here, now that we have our f of x plus h minus f of x, we can then go into our equation for the first principle. Now, the first principle says it is limit as h approaches 0 of f of x plus h minus f of x all divided by h. Now, we know what is f of x plus h minus f of x, right? So let's go ahead and open on the new board and see if you can write that. So first of all, let me rewrite again that part. F of x, sorry, limit as h approaches 0 of f of x plus h minus f of x all divided by h. Now, we've already calculated what is f of x plus h minus f of x, right? So now what you're going to do is we can just simplify, we can just substitute that, right? Minus 2xh minus h squared plus 7h all divided by h. Now from here, the only thing that you're going to do now, what is it? You're just going to take out the common factor, which is h, minus 2x minus h plus 7. Divide that by h, and then this cancels with that, and then you get limit as h approaches 0 of minus 2x minus h plus 7. Then from here we can substitute the value for h, so it's going to be 2x minus 0 plus 7. Then the final answer here is going to be minus 2x plus 7, and that is going to be our final answer. Now do you see how easy this is? Now the reason why we were doing f of x plus h minus f of x is because we wanted to break this thing down, right? Now breaking it down, first we had to first find what is f of x and find f of x plus h, and then find the difference between them, right? So the aim for that was so that when we come into the equation, when we substitute that, the only thing that we're going to do here is what is take out the common factor. Now you might be wondering, or you might be asking yourself, is this the only thing that you'll be doing if you do it this way? Of course, this is the only thing. Why? Because here you have already simplified everything here, and then here you are trying to avoid all the mistakes that you will get when you simplifying it on what, on the fraction, right? So that is why it is important that first you do it this way, and then write the equation. You just come and simplify the value here, or substitute the value here. When you substitute the value here, once you substitute, the next step that you do here is taking out the h so that it can cancel out, right? And then from there you're gonna substitute the value, then it's gonna give you the value for your f prime x. And I hope this makes sense. Let's go ahead and look into the second question. Now in the second question, 7.2 is saying determine f prime x if f of x is equal to 4 over x squared plus 3x to the power 5. Now let's first write f of x. Now f of x is 4 over x squared plus 3x to the power 5. Alright, now what's the first thing that you need to do here before you find f prime x? Now the first thing that you need to do is to make sure that our terms are differentiable, right? These we need to change, meaning we need to change these into a differentiable terms. Now what are differentiable terms? Differentiable terms are terms that are in this form. So here you see we have a coefficient, and then we have a variable, and then you see the variable is on the numerator, right? And then we have a power. Now here, this then means what we're going to do here is on f of x, what we're going to do, the first thing is we're going to change this one, because this one x here is in the denominator. So changing this is going to get 4x to the power minus 2, and then the second one is already in that form, right? So now from here, what are we going to do now? So from here, we're just going to go and differentiate. So f prime x is going to be, so to differentiate, when I take this one, minus 2 times 4x minus 2 minus 1 plus 5 times 3 x to the power 5 minus 1, right? Now this gives us minus 8x to the power minus 3 plus 15x to the power 4, and this is the final answer for our derivative. Now let's go ahead and look into 7.3. Now 7.3 says this, determine dy over dx if y over x minus 3 is equals to 1 plus x. Now here dy dx means it's a derivative, right? But now this is a derivative from a function that has y as the subject of the formula. Now here, as we see here, we don't see y as the subject of the formula, so we need to first make y our subject of the formula. Now how do we do that? Now here y over x minus 3 is equals to 1 plus x. This then means when I take this x minus 3 and multiply over, then this is going to be 1, y is equals to, and this one I can write it as x plus 1, and then this one is x minus 3, and then when I multiply everything out here, simplifying this, it's going to give you x squared minus 2x minus 3. Then from here we can see y is the subject of the formula, and not just the subject of the formula, it is a function of x. Then this then means now dy dx can be applied. Now dy dx is going to be 2 times 1 x to the power of 2 minus 1 minus 1 times 2 x to the power of 1 minus 1 plus 0, right? Then now here we get 2x to the power of 1 minus 2. Now x to the power of 0 is going to be like that, right? Now this is going to be 2x. Now any number to the power of 0 is 1, so this is just going to be 2x minus 2, and that is the final answer. Now I hope this makes sense in this first part of the three-part series of derivatives and first principle. Now if you like the video, please be sure that you subscribe so that you won't miss when another one gets uploaded, and I'm going to see you on to the next series. Cheers.